Yeah? No? Yeah? All right. With us here, we have another super talented guest speaker. So please give us a big round of applause to Dr. Arm.
Okay, knock, 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 knock. Okay, how are you guys today? If I'm speaking too fast, just raise your hand and tell, hey, PM, stop talking, something like that. You can say that, okay? So let me introduce myself once again. My name is Arm, and I'm from NECTEC, Thailand. I'm now a researcher working on large language model. But for today, I'm going to go back to the basics. How to use a large language model for your job, okay? I think you guys are working very hard on your job, and my slide for today will be just only for expanding your horizon. You may have known some of the contents already, and for some, I will expand your horizon, okay, for some topics on that. I've already provided a QR code for the slide already, so you can scan it up here, or you can just snapshot this URL. I think everything is already online, so please feel free to download the slide and get along with my rambling. Am I speaking too fast? พูดเร็วไปปะ? Am I speaking too fast? No? Okay, cool. So, I think I've got about, let's say, an hour, but my slides are designed for 40 minutes talk, just only 40 minutes. So, if you have a question, yep, feel free to do so. Yep, raise a question and share your knowledge. Yep.
Do we need to vote along?
Normally, you don't have to. Normally, you don't have to, but I already give you the collab. So if you would like to join me coding, you can also go for the slides, and the URL to the collab will be in there. Okay, so far so good. Just for the sake of, just for the peace of your mind, here's the link to the collab. It's already there in the slide, but if you want to join the coding, you can feel free to do so. Okay, so here's the link to the collab. Anyway, my talk would be more about basic knowledge, especially for large language model and how to use it using Hugging Face. So far, so good. Let me introduce myself once again. My name is Arm. I'm working for NECTEC since 2005, so it's been a long, long time. And yes, you can tell everything about me from my purple hair. Oh yeah, back in the day, I dyed my hair purple. But for today, because I'm working for a Thai government, so I cannot do that anymore, unfortunately. Anyway, this is the outline for today's talk. First of all, I'll be talking about zero-shot learning. Zero-shot learning is to use the knowledge embedded in the large language model for your job without any training. Zero-shot here, the word shot means example. So you don't need any training example at all. You can run the model and use the already embedded knowledge in the model for your job. Believe it or not, some of the ready-made applications like Traffic Fondue actually use this zero-shot learning. Everything in Traffic Fondue is based on zero-shot learning. And the next one will go for Hugging Face. You'll see many models. You'll see some of the models, like famous models, that you can actually include to your project and give it a go. And also the pipeline. You also see some commands, like basic commands for using it. And the next one, we go for something a little more advanced, which is few-shot learning. Few-shot learning means few examples for each class. You don't need much data to get your model ready. you can use the pre-made model plus your customized data set and get your model ready. And the last one, which I would like to talk about, is the retrieval augmented generation, or sometimes retrieval-based large language model. And just for advertisement, which will be given, which will be talked about this afternoon, the OpenType GPT. I'll let Dr. C talk about it afterwards, okay? He knows more than me in the project. Okay, so far so good. Okay, I think everyone is working on large language model, but I would like to provide some basic knowledge before we get into the details. The language model is actually statistical prediction method of how a string or a sentence is produced in a language. So basically, every word that is generated is taken into account by looking at the context. It means that if you know the context, you predict the next word. And when you predict that word, you include that word into the context and predict the next one. And you repeat the whole process over and over again. Mathematically speaking, we can interpret that as a generative model. Oh, that sounds complicated. Generative model means generation. So you generate one thing after another. It means that first, if you want to generate a sentence, you will begin from generate the first word without any context. So that is it. You generate the first word of the sentence by a probability distribution. When we say generating something from the probability distribution, it means that you throw a dice. And the dice will have a probability on each side or each face of the dice. So when you throw the dice, you get the first word. Then you take that first word as the context and predict the next one based on throwing the dice. And include the second into the first, and that is the context for the third word. And you repeat the whole process over and over again until you reach the end of the sentence. This is how we generate a sentence with respect to a large language model. Believe it or not, what I have said so far has been published at least 40 years ago. You can trace it back to 1980s. But with the advent of deep learning, we're now getting into the large language model. When I say large, it means that we need at least 1 billion words of text data to train a stable large language model. It imitates how we speak. It imitates how we generate a sentence based on our knowledge. And that is the basic idea of the large language model. The thing that makes it work are two factors. It learns word collocations and it learns phrase structure, the idioms. When I say it learned word collocations, it means that it knows if that word shows up, the next one will show up too. That is word collocation. Now let's think about your word. If you're working on the textual data and you want to guess the next word or the missing word or the missing category of a document, then word collocation will be your key. Also, if your language data is very complicated, sometimes you need to analyze the phrase structure. It needs not be just only an idiom, but also the order of words. The subject, verb, object, preposition, phrase, stuff like that. It can be learned automatically with the large language model. That sounds so imaginary, right? It works. Believe it or not, it works. Okay, let me show you how it works in practice. Everyone has heard about the name GPT, right? Generative, pre-trained, transformer. This is how GPT works in practice, okay? You begin with a content. You know that song, right? You know that song? น้องเป็นสาว What would be the next word? น้องเป็นสาว ขอนแก่น Yes. Then น้องเป็นสาวขอนแก่น ยังบ่เคยมีแฟนบ้านอยู่แดนอีสาน You know that? You know that song? You know the words, right? It's already embedded in your brain. And this is how actually GPT works. It gets the next word after the other. The term GPT means generative, pre-trained transformer. That's because the underlying foundation model is transformer. And the model of transformer actually learns word collocation, phrase structure, and a dictionary. Oh yes. That's why I love the model so much. It looks so unreal, but actually it works. The transformer model, which was invented in about 2016, it was actually meant to be a sequence-to-sequence generation where you put an input sequence and it generates an output sequence. So it means that you put a string in and then you generate another string out. That's it. That's the basic idea. The sequence-to-sequence model has been around for ages, since 2010, if I'm not mistaken, since 2010. But now it becomes transformer. The transformer was actually designed for machine translation, believe it or not. Google Translate that you're using today is actually based on transformer. The basic idea is very simple. You've got a source sequence, and then you learn how to generate the target sequence. What it learns are word collocation. It learns where the idioms are. Because when you do the translation, you need to detect or identify the idioms. Where are the idioms? Like look after, take into account, kick the bucket. Kick the bucket means to die. Things like that. If you don't know that idiom, how could you actually translate that? So that's the first task. It learns word collocations. And on top of that, when you learn word collocations, it can also learn collocations of word collocations. And you can build that up. From just only word collocation, you can now learn the tree, syntactic trees. And that is the phrase structure. And to do the proper translation, you need to build up a dictionary. Technically speaking, it's called translation alignment. Alignment means mapping. So it learns how to map phrase to phrase translation. And that is the basic idea of transformer. It learns three things: word collocations, phrase structure, and translation alignment. If you're working on transformer, you may have to think about translation. You have to form your problem as a translation problem. If you can formalize that, then your problem will become a lot easier to think about. However, as you can see, the transformer model consists of millions and millions of parameters, or millions and millions of neurons. It takes a lot of time to train, and it consumes a lot of data to converge, which means you need a lot of data. That's the basic idea. That is why we never train the transformer from scratch, because it's going to take a lot of time and a lot of data. We would do fine-tuning instead. And in the afternoon, Dr. C will teach you how to do the fine-tuning properly. So far, so good. Has anyone any question? Any question? Knock, knock. You can actually raise your hand and ask a question along the way. It's okay. It's okay. Other than that, I'll carry on rambling. Rambling means พูดโม้ไปเรื่อยๆ ramble.
If you are comfortable to ask any slide, do so as well.
It's okay.
เราก็จะพูดไทยได้นะครับ
แรงมากทำภาษาไทยได้นะ but I've got to speak English. That's how the organizer briefed me. Okay, no question at the moment, so I can carry on. Okay, if I'm speaking too fast, you can always raise your hand and you can say slow down, slow the fucking down, something like that. You can say that too. Okay, anyway, I think you guys have heard about Hugging Face. Hugging Face is a community of researchers. They publish the data set, they publish the model, and they also publish a new neural network architecture over there. So I want you guys to check that out. I think you guys have already done that. Most of you would actually have used it at some point of your life. And I love it too. I love Hugging Face so much that I encourage everyone to use it. I'm not saying it's a way to go, but it's a good way to boost up your productivity. You don't have to work everything from scratch. Okay, so that is Hugging Face. And for today, we'll be talking about how to use Hugging Face, not properly, but from my experience, okay? Everything you see from my slides is actually my own experience. Okay, and I have given you the URL to the Google Colab. That is the real thing. That's the actual thing. I teach this course. Actually, it would take about 6 hours to cover everything in the slides. 6 to 9 hours. Okay, but for today, I've got only an hour. So I've got to breathe through my skin. กูต้องหายใจทางผิวหนังละหนึ่ง Okay, but anyway, I'll show you around what's inside my Google Colab, okay? So that you can scroll through what's going on, okay? And in the Google Colab, I also distribute my slides for the transformer. If you want to get into technical details about transformer, you can also get to my Google Colab and the slides will be there. It differs from this slide, okay? It completely differs from this slide. So far, so good. Let's get on with the technical stuff, okay? I'm always looking at the clock on my laptop because I'm so considerate of your time, okay? That's me. Okay, so the first topic is zero-shot learning. Zero-shot means zero example. You don't need any example for your model to work because you can use the embedded knowledge. In the large language model, believe it or not, zero-shot learning has been around for ages. And it was first invented in the image processing long time ago. Let me tell you what it is, okay? Back in the day, when they trained the image processing model, like object detection model. So you would put an image and you train the neural network to produce a class, okay? To identify the class of that object. Like this is a dog, this is the parrot, and this is a fish. So you detect that. Okay, you output the class with respect to the one of the output neurons. Okay, so if this is a dog, then this neuron will produce 1, the rest will produce 0, things like that. But the revolutionary idea at the time is that instead of producing just only 1 hot output vector, we now produce a word vector. We train the model to take an image and generate a vector for that class. Let's say a vector of the word dog, a vector of the word parrot, and a vector for the word fish, things like that. So it means that we are now training the model to project an image features, like brown hair, 2 eyes, 1 nose. All these features will be projected into the space, and you project a point in that space to a word embedding vector. So you try very hard to project from the features to a word vector. That is the training process. The basic idea is very simple, but what they found is very intriguing. Intriguing means interesting. Intrigue แปลว่าทำให้สนใจ Intriguing ทำให้น่าสนใจ Okay, so this is the intriguing point. They put an unknown image. They put an unknown image like that Siamese cat. They put that as an input, and it produced the word embedding for cat without any training. Because the model learns to project the features into the space of word vectors. So it does that as you prescribed. Therefore, if you have an unknown class like that, although you've never seen that before, it can still make prediction. And that is zero-shot learning. Zero-shot learning is very useful when you've got a pre-made model, pre-trained model, and you somehow would like to use it straight away. Most pre-trained models today can do this, believe it or not, because of the transformer. If you map everything into language, just like this one, the output is a word vector. I forgot to mention this is a word vector or word embedding. So if you map everything into a word vector or word embedding, then it starts to share the knowledge with physical world, the world of language. It means that you can link cat to Siamese cat because they are similar. You can link cat to fish because they have some relation, things like that. So this is a zero-shot learning. You use the already embedded knowledge in the model to do prediction without any examples. Zero-shot learning. I love it so much. And believe it or not, this kind of prediction has been used in many projects, especially government projects like traffic fondue. Have you ever heard of traffic fondue? Oh yes, that one. When you've got about 400,000 queries per day, 400,000 queries or complaints, I would say, how would you classify them automatically and run it in time? I'm not saying about on time, in time. เอาแค่ทันเวลาก่อนน่ะ How can you manage that? How can you develop the model so that it can handle 400,000 complaints? And you have to do classification, all of that, into various departments. Zero-shot learning can deal with that. This is an example. I'm not saying it's from traffic fondue, but it's very close because I copied that from traffic fondue and then I modified that. Okay, so this is how I do. Okay, so here, this is an example from Hugging Face, okay? I use Hugging Face as an example. And the command pipeline is for model pipeline where you put an image and then you construct the model automatically, the input, and then you construct the model. You also do the pre-processing and then make prediction and clean the output. So that is the pipeline. It consists of 3 steps: pre-processing, and then prediction, and then post-processing. So the pipeline takes care of everything. Here's the pipeline for classification. So I say zero-shot classification, you specify the task, and then you specify the model. If you don't specify the model, it will choose the best one for you, which you will never know which one you will get, okay? but it will choose the best one. And the command get device is for detecting your GPU card. So that is a pipeline. And then I said, หมากปรินเผยไม่เคยปิดบังว่ามีแฟนแล้ว And then I ask it to classify that text into 4 unseen categories. 4 unseen categories: politics, economy, entertainment, and environment. And you just put the text and the labels into the model, and it will give you the probability of each class automatically. You never trained that before, but still, it can make prediction, and it's quite good. And it's quite good, believe it or not. However, when you use this kind of zero-shot learning, you may have to take into account the probability here. If the probability, because the probability is actually the confidence. If the confidence is too low, somehow, let's say less than 40%, then you may have to reconsider your approach, okay? For me, I've got about the cutoff line at 40%. If the probability is lower than that, I may have to reconsider my approach. I may not be able to use zero-shot learning anymore. And you'll see the next one. And this is how we use it, zero-shot learning. Easy, right? Oh yes, very easy. You use a pre-made model to make classification, to do the classification. And you can also do this. This is a film mask. Film mask is actually one task of the large language model. Film mask mean word guessing. You put a blank, and then you ask the model to fill in the blank, just like this. This is the blank. Model.tokenizer.mask token, that is the blank. And then it will show up like this. The text, the input text is like this. Mary has lost her beloved dog and her eyes are now tearful. Can you show the emotion of this text? Things like that. This is emotion detection. And you use zero-shot learning to do that. Easy, right? Oh yes. And then when you run the model, you've got the output just like this: sadness, disgust, tears, sorrow, disappointment, things like that. And then you screen them out. Some of the output classes will be nonsense. It's okay, just clean them out. Still easy, right? Oh yeah, zero-shot learning, it helps you a lot. As I aforementioned, traffic fondue, use it all the time. We don't have any data for training because we don't do annotation. We're too lazy, okay? You know, as a government agency, we are lazy. We don't do annotation at all. Or we hire someone else to annotate for us. Oh, have I revealed the secret? Okay. And on the hacking phase, okay, I'll be staying here too, okay? So that everyone here could see my face. Okay, so some of these models are available on the hacking phase, but we don't limit ourselves to natural language processing or the NLP. There are a lot more. NLP is the majority, I understand, but there are a lot more than that. You can also have the conversational agent where you can specify the persona of the agent. You can specify the characteristics of the bot, the robot, and then train it with your small data set. It works. Like Pygmalion AI, you can swap around the language model to let it speak Thai, and then you've got a chatbot in Thai. You've got a film mask, just like what you have seen so far, zero-shot classification, question answering, table question answering. Oh, I love it. I love this model. You put a table in, and then you can ask a question regarding the table. And then you've got like machine translation, like you've got many language pairs. It's not limited to just only English and something else. You've got Thai, you've got Burmese, you've got Cambodian, for example, Khmer, things like that is already there, but the model is not that good, I would say. If you've got a low resource language, then the translation would not be so reliable. But for English Thai and Thai English, it's quite reliable. I love it. I love the model. Okay. And that is translation. You also have the speech processing, like Whisper and things like that is already there. If you have heard about Whisper, that's for ASR, speech recognition. And you also have HyperSec. Has anyone heard about HyperSec? HyperSec, hyper, and then SEG, hyper segmentation. HyperSec is a very good NLP module for topic segmentation. So if you transcribe a long sequence of speech, let's say 2 hours of meeting minutes, okay? You use HyperSec to segment the topics automatically and unsupervisedly. It's so accurate, believe it or not. It's already there on Hugging Face. And also you've got image processing. You can do image detection, object detection, mass generation and stuff like that, and zero-shot classification. All of these are listed. And also you've got the multimodal processing, like image and text, image and speech and text, things like that. So yes, I love it. Especially this one, visual question answering. You've got an image, and then you can ask questions according to the image. Think about that. You can create a lot of, I would say, questions and platforms regarding these fundamental models. We would say it's a foundation model, and we love it. Oh yes. That is why when we come up with a new model, we want to contribute to the community by publish it on the Hugging Face so that everyone can build the system on top of that. So far, so good. And let me show you how easy that is. If you come up with a new sentiment analysis model, telling the polarity of the text, like this one is positive or negative, you can publish the model according to that, and it's quite easy. Sentiment analysis is very important. It's crucial for social media mining, where you want to detect the polarity in the social media. When you launch a new product and you want to see, oh, how people would react to your new product, things like that. So sentiment analysis is quite the key here. And the sentiment analysis is available in many Thai large language model. So it's already there. Use them. Try them all. Why not? Try them all. Okay, and that is the Hugging Face. Everything is on Hugging Face. I love it so much. I'm not advertising for Hugging Face, I would say. I'm not doing that. I'm teaching you the foundations of building applications on top of that. Okay. Okay, let's get on with the new topic, few-shot learning. This is a place where your zero-shot learning doesn't work anymore. As I aforementioned, I've got the cutoff line at about 40% of the probability. If the prediction, the zero-shot prediction gives you like 39% of probability, then you may take this approach into account instead. This is called few-shot learning. Few-shot means few examples. ตัวอย่างไม่ต้องเยอะก็ได้ Okay, that is few-shot learning. The few-shot learning is a kind of meta-learning. In machine learning, there are two kinds of learning tasks. In the theory of machine learning, there are two kinds of learning. Okay, the first one is classical learning. Classical learning means you've got an input, you've got the output, and you build a model. That is classical learning. You learn how to produce the output from the input. That's it. But you've got another kind of learning, we call it meta-learning. Meta-learning means you learn how to build the model from the input and output. Learn to learn. This is a different task. Instead of learning to build, you're now learning to learn. Meta means alternative or up above. That's meta. Meta แปลว่าเหนือขึ้นไปหรือถ้าแปลเป็นไทยก็คืออภิเช่น metadata metadata เนี่ยราชบัณฑิตแปลว่าอภิข้อมูลซึ่งแปลไทยเป็นไทยแม่งก็ไม่รู้เรื่องเพราะนี้เรียกว่า metadata ต่อไปเนาะโอเคสำหรับอันนี้พูดไทยแป๊บเดียวสำหรับอันนี้ meta learning คือการเรียนรู้ที่จะเรียนมันจะกลับกันแล้วนะ machine learning คือการสร้างโมเดลแต่อันนี้คือการเรียนรู้เพื่อที่จะเรียนที่จะสร้างโมเดลคือแม่งเรียนสอนเรียนโอเค that's all for Thai okay so that is meta learning you'll see this in a minute okay meta learning is easier than you think when you say hey meta learning is complicated you learn to build a model how the fuck can we do that okay. Instead let's take a look at this task okay so we've got small data set where each class consists of only a few examples. Let's say you've got a class of Labrador, okay, Labrador, and Saint Bernard and a pug. Okay, so you've got 3 breeds of dogs. And for each of them, you've got just few examples. Let's say 4 pictures, 5 pictures, and 3 pictures. All that. Instead of learning to build a model, no. You learn the similarities inside each group. And you learn the dissimilarity among the other groups. See, the keywords are here. You learn similarity and dissimilarity. ความเหมือนกับความต่าง Similarity must be inside each group. Dissimilarity is between 2 groups. You want to see how inside a group they are similar and among different groups how different they are. You want to learn the 2 things, similarity and dissimilarity. How can we do that? In machine learning, we can do this by coming up with a new model. We call it similarity model. The similarity models work just like this. You've got 2 items or 2 pictures. You've got 2 pictures, x and x prime, okay? If x and x prime belong to the same group, it means that the similarity of x and x prime should be 1. They're in the same group. They're similar, you return 1. If they belong to different groups, the similarity between x and x1, x prime should be 0. It's as simple as that. Now, the similarity model can be anything like neural network, support vector machine, or anything. Most of the time we use neural network because it's easiest to train. So we come up with a new model like neural network for similarity model, and then we train the model according to it. We choose items in the same group and force the loss and force it to produce 1 by using the loss function. And then we choose items among 2 different groups, and then we say the similarity should be 0. And then we train that using stochastic gradient descent. Just backpropagation, simple backpropagation. However, you can't just choose items of the same group. You have to choose items from different groups. This type of idea is called contrastive learning. Contrastive learning means when you learn something, you learn both sides, contrastive. You learn the 1, the positive, and you learn the negative, the 0. You need to learn both sides, and you need to balance the amount of data on both sides too. Now you're thinking about implementation, right? How to write a program for doing that. You don't have to. It's already there on Hugging Face. It's called SetFit. It's on my Google Colab. You can check it out. So let me show you how to do that on Hugging Face. It's a lot easier than you think. You don't have to deal with many things. Okay, let me show you how. What you're seeing here is a data set on Hugging Face. We call it Tweet Eval. Tweet Eval is a data set based on tweets, okay, Twitter. And then volunteers annotated a lot of them. Like this one is stands for atheism, okay? คนไม่มีศาสนา okay? Stance mean ท่าทางหรือทิศทางหรือความคิด And then you've got classes. You've got 3 classes. 0 mean nothing. 1 means he's quite religious. And 2 means atheism. Okay? So you've got 3 classes. You don't need a lot of data. As you can see, you've got about just that. Oh yeah, that small data. 461 rows of data. And that consists of 3 classes. Wow. With this small data, you can still train a model. With SetFit, you can basically set up your trainer. I mean, field shot learning trainer according to your model and train the model with respect to the data. And you've got quite good accuracy. And that is only small data set. It means that if you have a small data set, you can still deploy your model. Think about it. Is any step in your pipeline needs a lot of data, but you don't have one? Why don't you try the field shot learning instead? It's a lot easier. Sometimes I don't want to read these texts because they're very, I would say it's very racist, and I don't want to read that out, okay? But that's a test model. I'm not kidding. That's how we test it. Okay. Next one. When your project consists of chatbots, modern chatbots are now based on large language model. And it will be even better if you can include local data sets to your chatbot. It means that you can ask a question, it answers to your question, and at the same time, it can get access to your documents, your local, sometimes access control data set, and get the answer out. At this point, we use the retrieval augmented generation. The idea is very simple. It's much simpler than you think. This is called the RAG. I would call it RAG from now on. RAG is like this. It's actually Google Bard. Has anyone used Google Bard? Yes, I think you have. It's RAG in disguise. This is how it works, okay? In the large language model, it processes the input sequence and produces the output sequence. But in RAG, you've got an additional step. Once you've got a query, just like this, the question say, the something at the top of the pyramid. This is a query. And you need to fill the mask, okay? What is something? How would you call the top of the pyramid? Okay. If you don't have that knowledge inside the large language model, you need to look for relevant documents. So at this point, you need an information retrieval module, Elasticsearch, vector database, things like that. So you put that question into the information retrieval system and retrieve relevant documents. When you retrieve those information, you attach those information after the query. So this is what you have retrieved. The pyramid on top allows for less materials higher up the pyramid. So you attach that information after the query. And this query and relevant information will be passed to the traditional large language model. Now, the large language model will have the context of the query. This is called in-context learning. It means that you provide the context for the large language model or the chatbot. And then the chatbot mix up the question and the information and get you the answer. It helps with the problem of hallucination. I'm not saying that it solves the problem, but it mitigates the problem. It mitigates the problem of hallucination. At least you've got some reference, some citation for the large language model. And that is the secret of Google Bard. It retrieves the data from Google and then attach that to the query. Easy, right? You can think about your application, right? No, everything has been proposed. So you can make use of ready-made modules like LangChain. LangChain is very good. It's a platform for RAG, Retrieval Augmented Generation. It's so customizable because it has templates. It provides templates for you. So you can choose templates of, for example, question answering system and information retrieval and document preparation system, things like that. You can prepare the template according to your demands and deploy your system. And it's very easy to maintain your system as well because it has got everything in there. However, people complain a lot. People complain about LangChain because it's sometimes too complicated. I would say when I use it at first glance, I said it's fucking complicated. So I opt for the other one. The other one is called Local GPT. Local GPT is a wrapper of LangChain. It's much easier to deploy on your system. Much easier to deploy. Within like 5 commands, you get your system ready up there. And it's also based on LangChain. So when you get your system ready, you can work on top of that. And if you need more customization, you can dig deep into the LangChain and customize it. I would recommend this, Local GPT, for getting started, okay? Very user-friendly. So far, so good. Have I revealed my secrets? Not yet. And the last part is OpenThai GPT. This is for advertisement, okay? This is for advertisement. โฆษณานิดนึงเนาะ ขายของ Thai in เนาะ Thai in. Okay. OpenThai GPT is a large language model for Thai. And we've got some of the team members around here. They mingle with you guys. Okay. OpenThai GPT is a collaboration between 3 bodies, okay? NECTEC, AIAT, and AIEAT. Okay. Dr. C. Gopkit will talk about the details in especially the getting your hands dirty in the afternoon. So get ready for your workshop. Okay. Anyway, the OpenThai GPT is trained on a very large data set. How large? Oh yeah, you can try it out over here. The system is actually based on AI for Thai at NECTEC. So happy to go. Why not? Happy to go. Have it a go แปลว่าลองดู Okay, so this is a data set. We crawl about 2 trillion tokens. 2 ล้านคำใช่ไหมม่อน ใช่ไหมแฮร์รี่ใช่ไหมปริน yeah just about that the team members yeah and so we crawl about 2 trillion words or I would say tokens token means subwords คือโอเคคำว่า token หมายถึง subword subword ก็คือเศษคำเนี่ยคือ prefix suffix root ทั้งหลายนะมันจะแบ่งเป็นก้อนเล็กๆเราเรียกว่า token so we crawl about 2 trillion tokens and we clean the data I would say it's not just cleaning but cleansing เหมือนกับจับไปล้างน้ำคือ clean แค่เช็ดใช่ปะ cleansing คือล้างน้ำแล้วแช่แล้วแกว่งด้วยเอาไปนานๆแกว่งอันเนี้ย cleansing okay so we cleanse the data for a long time we do anonymization we do care about PDPA chapter so it's really important so we end up with just only 37.3 billion tokens imagine that from 2 trillion to just only 37,000 millions think about that we lose a lot of data because of the anonymization deduplication and all sorts of things luckily we've got Pantip they donated about 20 billion tokens so we've got about 60 billion tokens and we train the model accordingly and we train the model based on Llama version 2 it means that everything that you have got on Llama version 2 the knowledge the embedded knowledge everything there is already there and applied to Thai as well so it can do many things like machine translation it speaks English too it speaks Japanese it speaks Chinese it depends on your configuration and the generation is now based on word not just only character based originally the Llama version 2 is based on character generation but now we modify that to make it word level for much more accurate generation and the tokenizer is BPE byte pair encoding if you want to know more about that I can explain it to you what the BPE means and this is the demo but now it's not beta anymore it's more like almost RC1 and if you take a look at the leaderboard I retrieved this leaderboard from the 14th of September we're still up here but the leaderboard may change over time so bear with us okay we're still on top of there and we evaluate our large language model based on the data sets for common sense reasoning it means that we want to evaluate if our model has got some common sense just like human do and we say okay it's getting there but it's not perfect okay it's getting there and we're waiting for you guys to fine-tune the model and get it better improve it okay it's free this means it's free on Hugging Face you can download that today and fine-tune it and at NECTEC we have a lot more projects to go Llama version 2 is one of them and also we are training Nemo Megatron but our high performance computing is still down I'm sorry Lanta is still down so we have to postpone the project of Nemo Megatron so we want to train a very large one not only just 7 billion parameters and 13 billion parameters we want to try like several hundred million parameters instead things like that and we also training Electra, BART, Liberta and some multimodal language model as well but for example he's responsible for multimodal models oh yeah team members yeah and things like that and our aim is to make Thai as one of the pivot language in ASEAN countries Just like we treat English as a pivot language, we want to make Thai as one as well. But that means we need a lot of you guys to contribute to the project. So far, so good. Let me conclude what I have said so far. We begin with the large language model. We train the large language model, the statistical prediction of how sentences are generated based on probability distribution or from statistical model. And to make it large, to make a language model large, we need at least 1 billion words of training data to make it reliable. Next, we have learned zero-shot learning. Zero-shot means 0 examples. We have 0 example, but somehow we use embedded knowledge to get it to work. That is zero-shot learning. Then we look at Hugging Face library, where we take a look at ready-made models and the pipelines. We know how to use it, or we will know how to use it in the afternoon, okay? And few-shot learnings, we have learned the meta-learning, learning to learn to build the model by comparing the similarity inside the groups and dissimilarities among different groups. You train the model accordingly so that the model learns to distinguish similar items from dissimilar items. And RAG, retrieval augmented generation. If you can decide that the query is beyond the embedded knowledge, you query relevant information from local data set and attach that to the query, and then put the query into the large language model to get the answer. That is the RAG. And you have seen the OpenThai GPT, which is a Thai language model. You can try it out today, it's already there. And when Lanta is up again, we will launch the RC1 and the full version very soon. So I think that's all for today. Time for questions. ถามไทยได้นะครับ
I probably need to have disclaimer later that I'm not a technical person.
Okay.
My question would be, I have tried a lot of the OpenAI ChatGPT before.
Sure.
And there is a feature where it's sort of like browsing the search engine feed, and they try to retrieve the information from the browsing, right? So my question is that, is it some sort of RAG?
Exactly, that it is. RAG is trendy, even at ACL, the mainstream conference for NLP. Like last year, I mean this year, most paper will be about RAG. Yes, please.
So I want to ask regarding about the RAG. I've tried like adding embeddings to the query, but it kind of slows down the performance when we add too much. Is there suggestions or anything you can help with fine-tuning that?
Oh yes, that's a very good question. Okay, so when you attach the relevant information into the query, you may have to screen it out first. You don't attach everything into it. That's because of the token limits, the length limitation of the transformer. The big O, the time complexity for the transformer is big O n squared. So the more you add to the query, the longer it will take to compute. So I recommend you try to cut short or summarize the information before you attach to it. That is the first thing, like the ad hoc solution. But in the long run, I recommend more GPU power, because at the end of the day, you will need more information so that it will help getting the answer right. Sorry for that. Yes, please. คนกันเองอยู่แล้ว
Okay.
Just quick question, but might not related to the technical point of view. So
Okay.
because I saw some slide that you just mentioned about the hacking phase, they have already used the model, right?
Yes.
So I would like to ask about the based on the usage point of view. So hacking phase allow us to use only the R&D point of view, or we can use it for the commercial as well.
I think you can use it for commercial products. Yes.
Okay.
Everything is, I think, CC, Creative Commons. So you can use it for free, and you can use it for commercialized products as well.
Got it.
Yeah. Am I speaking too fast? Yes, please. ครับครับ
พูดถึงเรื่องที่เพลงแล้วเกี่ยวกับข้อมูลนะครับก็ถามก่อนว่าไอ้ตัวที่เพลงนะครับเวลาใช้มันต้องดาวน์โหลดมาเก็บในข้อหรือว่ามันถ้าเป็นแบบเขาโพสต์โมเดลให้ด้วยอะไรมันเป็นฟิกเกอร์ยังไงอะไรอย่างเงี้ยครับแล้วก็เบสแพคทิสอะไรพวกนี้เป็นยังไงแล้วก็ผมมีคำถามเกี่ยวกับมันที่เพลงแบบอาจารย์ชอบใช้นะครับคือก่อนหน้านี้ก็คือรู้จักมานานเป็นคอมมูนิตี้เนี่ยแต่พอหลังๆเมื่อไม่นานเนี่ยทราบว่าแบบเขาแบบเป็นยูนิคอร์นพันล้านเขาขายของอะไรเนี่ยก็เกิดกันเราใช้ฟรีกันอยู่อะไรอย่างเงี้ยครับมันก็
โอเค คือจริงๆแล้วครับไอตัวโมเดลพวกนี้อันนี้ผมยังไม่ได้เห็นราคาเขาเนาะแต่เขาเริ่มเสนอแล้วว่าถ้าเกิดจะโฮสต์โมเดลเฉพาะของบางบริษัทอย่างเงี้ยเขาก็มีบริการให้นะแล้วก็จะได้ใช้ง่ายขึ้นแต่ผมยังไม่เห็นราคาจริงๆอันนี้สารภาพตามตรงยังไม่เห็นราคาเพราะว่าเรายังไม่ได้คุยกับเอกชนในฝั่งแบบนี้เลยแต่ก็รู้ว่ามีแบบนี้ครับมีอย่างที่ว่าเลยมีอย่างนี้เลยแล้วก็คือผมมองว่าเป็นโมเดลที่เป็นคอมเมอร์เชียลมันมีด้วยนะโมเดลเป็นคอมเมอร์เชียลอย่างเงี้ยเขาก็จะแบ่งรายได้ส่วนหนึ่งที่มีคนซื้อไลเซนส์โมเดลไปแล้วก็เขาก็ทำกำไรจากตรงนั้นแต่ถ้าพูดกันตามตรงคำว่ายูนิคอร์นแปลว่าป่านนี้ยังไม่ทำกำไรแรงไปไหมเนี่ย no นั่นแหละครับ it's not that profitable like look at OpenAI still not profitable at the moment I'm sorry ป่านนี้ OpenAI ยังขาดทุนอยู่เลย Any other questions any comments or you can say พี่อ้าม stop mumbling มาพูดพึมพำอ้าวแฮร์รี่
คือเห็นว่าแรงอย่างเงี้ยมันมีหลายมิติแล้วก็มันกำลังมาแรงใช่ไหมอยากได้แบบนี้แบบว่าเป็นเปเปอร์หรือว่าไกด์ไลน์ที่ว่าดีเลยที่แบบว่าเราควรจะแบ่งชั้นยังไงเราควรจะให้เทคมันอะไรกันยังไงเพื่อให้แบบว่ามันต่อได้แบบเจ็บ
อุ้ยอันนี้เปเปอร์ใช่ป่ะเดี๋ยวพี่หาให้ได้ป่ะคือพี่เคยเห็นเปเปอร์นี้แต่ไม่ได้เซฟเอาไว้เดี๋ยวพี่ไปขุดให้เพราะว่าพี่คุ้นตามันมี best practice ของมันอยู่ว่าจะ set RAG ยังไงแบบ align ข้อมูลยังไงอะไรอย่างเงี้ยมันมีอยู่แต่หลักๆแล้วbest practice อันเนี้ยใช้กับภาษาไทยไม่ได้เพราะอะไรรู้ป่ะต้องตัดประโยคก่อนจริงมันช็อกตรงเนี้ยพูดภาษาไทยนิดนึงนะครับแต่จะบอกว่ามีทางแก้เมื่อกี้เนี่ยเราพูดถึงคำว่า hypersec เนี่ยมันเป็นโปรแกรมที่เอาไว้ตัดท็อปิกอัตโนมัติอันนี้มันอยู่ในเปเปอร์ใน interspeech เพิ่งออกมาปีนี้เองเลย hypersec hyper แล้วก็ seg เขียนติดกัน hypersec อันเนี้ยมันเป็นโปรแกรมที่เอาไว้ตัดท็อปิกอัตโนมัติคือหมายความว่าถ้าเรา transcribe สัญญาณเสียงเป็น text มายาวๆเช่นบันทึกการประชุมของ CP ขออนุญาตที่ต้องเอ่ยชื่อเพราะเราเล่นกับข้อมูลนี้จริงเอาข้อมูล CP มายาวๆเลยเสร็จแล้วให้ Hypersec มันแบ่งตามวาระการประชุมอัตโนมัติมันแบ่งโคตรเป๊ะเลยแล้วเป็น unsupervised ด้วยมันไม่เคยเห็นแม้กระทั่งข้อมูลภาษาไทยมาก่อนแล้วมันไม่ได้ใช้สัญญาณเสียงด้วยนะมันใช้แต่ text เพราะฉะนั้นเนี่ยพี่เลยมองว่าเอา Hypersec มาแบ่ง data ก่อนแ แล้วเสร็จแล้วโยนเข้า IAG ก็อาจจะพอช่วยได้นะเป็นการตัดประโยคแบบ unsupervised
คือ1 ครั้งคือ1 ประโยคหรือว่า
ก็ถ้าเกิดพี่แนะนำก็1 ครั้ง 1 ประโยคนะตอนนี้นะแต่มันจูนได้ไงคือไอ้ hypertext เนี่ยมันจูนได้ว่าจะเอาแบบยาวแค่ไหนมันจูนได้แล้วก็จูนสั้นๆก็ได้เพราะตอนเนี้ยเวลาเราทำ IAG อ่ะรู้นะหลายคนทำอยู่เราชอบแบ่งเป็น512 คำใช่ป่ะแบ่งกับไม่แคร์โลกอ่ะไม่แคร์เวิร์อ่ะแบ่ง512โยนไปเรื่อยๆแล้วจะรู้ได้ไงว่านี่คือประโยคจริง hypertext ไปแบ่งดีกว่าง่ายกว่าเนี่ยเห็นป่ะ
Okay. Any other questions?